All right, hello and welcome. This is the Kubernetes SIG storage community meeting about per volume CSI capabilities. Looks like we have pretty light attendance today. And so as promised last week, I'm going to sort of offer a slightly more detailed sketch of what my idea is and solicit feedback. But we may have to wait till next week to get more people involved to see if this is the direction we really want to go and if everyone's on board with this or if this is a dead end. So scrolling down here to my agenda. So here's an example of a Kubernetes persistent volume. And specifically what I'm suggesting we could add that would address all of the problems.
You might make this a little bit bigger.
Oh.
I don't know if it's just me or maybe my screen is too small or something.
I have a pretty large monitor, but
I can see it, but it's better if you that's better, much better.
Okie doke. Yeah, so here's it zoomed in. So here's a persistent volume with all of its fields, yada yada. The crucial thing is every CSI PV, this is a PV of type CSI, has this driver field. And currently that's the only information Kubernetes has about, or this only non-opaque information about what kind of volume it is. And we use this to look up, the CSI driver object and get all those proprietary Kubernetes options. What I'm specifically suggesting we could add is a sibling field called subtype to the CSI PV spec. This would have to be an alpha field. For backwards compatibility, it would default to empty. Empty would sort of imply the existing behavior, just do what we already do. But we could in principle add this to Kubernetes to sort of track on a per PV basis not only what the driver type is, but what the subtype is as well. And this could just be another sort of opaque string similar to the driver name. We'd just have to define what is allowed and what's not allowed, but it would just be a string. And then the idea would be, so that would be the only change on the PV side that we would need to do this proposal. On the CSI side, currently when you do a create volume RPC call, you get back this volume object. It's the only field in the create volume response. And in the volume, you get 5 fields. What I'm proposing is we add a 6th field called subtype as an alpha field on the CSI side. And again, this would default to false. And it would default to the empty string, and the empty string would imply, do the backwards compatible thing. So existing drivers that don't have subtypes could totally ignore this feature in this field, right? You just leave the field blank, an empty string will get put on the PV, Kubernetes will continue working exactly the way it does. But for CSI drivers that have multiple subtypes, they could start filling in this field. The external provisioner could start putting them into this field of the PV, so they would be accessible. And then Kubelet, when looking up various options like the FS group policy or the SD Linux change policy or any of those other policies, could look at this field and say, okay, if it's empty, do what we're currently doing, but if it's not empty, do something smarter, right? Where something smarter could involve, again, calling the CSI driver or looking at some map in the CSI driver CRD, or we could have multiple instances. We still would have to decide exactly how you want to handle the out of spec stuff that goes into the CSI driver CRD. But the idea would be you would have a key to look up different options, and then the way we would tackle per node volume limits would be to modify get node info response with a 4th field that would be a map. So today it has this N64 max volumes per node. This would continue to be used for volumes with the empty subtype, but for volumes with the non-empty subtype, they would use the values from this map. And
so the type basically defined by the driver. It can be anything. It's the string. Right?
Yeah. So for a driver like the NetApp driver that does NFS and iSCSI, it could literally be the strings NFS and iSCSI would be the 2 types. And you could, in principle, have different per node limits for NFS and iSCSI that would get returned here. And of course, there'd be a separate 3rd limit for the empty one, which would be provide backwards compatibility. So that would be the overall limit. And we would have to modify some of the internal Kubernetes stuff to communicate to the scheduler these multiple values. This is a map string in 64 as opposed to just one in 64. But we could, figure out how to communicate to the scheduler on a per subtype basis what the volume limits are. And then of course the scheduler can see for the PVs what the subtype is. So the scheduler could also be updated to do something smarter if the subtype was non-empty. And of course the subtype field, being a new Kubernetes field, would have to be feature gated, and it would default to alpha and default to off. So for the first release, no one would see this, but we could start adding in all the logic around it. In the second release, we could flip it to beta and turn it on, and then any CSI driver that was implementing this feature here would start filling in that field, and you start getting new behavior. So within
this is actually on the because the type is actually added this that create volume times is like controller side could also use this. And also since you're proposing
yes
scheduler, right? And
yeah, so what I wanted to emphasize,
other issue could be the second issue that we were talking about the other day, the two one is by volume limits, the other one is the non-published nodes or something, or two. So potentially the second one might be addressed by this because we are changing the scheduler side as well.
Well, the issue is that calls like list volumes would not be directly changed. Now, list volumes returns a message of type volumes, so you would get the subtype for everything you listed, but whether the published nodes was populated or not is an all or nothing capability today.
So basically would be, we would need to propose something else too, but I was just saying
we could, yeah, in principle we could say, okay.
Not saying it has to be completely addressed. I'm just saying since this change would actually change the controller side, so then it's possible that one can be also based on this one, make some changes.
Yeah.
Maybe later on.
Yeah,
I thought initially we thought we are not going to touch the scheduler. Since this is going to touch the scheduler, then
well, we only have to touch the scheduler if we care about fixing the max volumes per node problem, right? The other problems, we could fix independently and just not do this part of the change and not touch the scheduler, and we would be fine. But I just wanted to emphasize that this approach does allow us to fix the scheduler problem with different max volumes per volume type if we want to do it in this framework. I wanted to contrast this.
Potentially there'll be more issues than those two that we mentioned. Right? The potential could be other things. We just have not really, elaborated. But
I wanted to draw the contrast between this proposal, which, it's one CSI change to add this field and potentially this other field that we would do one time. It's one Kubernetes API change, and it allows us to basically continue then using our existing out of CSI spec hacks in the the CSI driver CRD, right? Because that's the approach we've used up to now to basically specify non-CSI behavior that's Kubernetes specific.
So hold on a second. Now, what are the changes we're going to make in the CSI driver object itself? This is
I didn't detail those because there's multiple ways to do it.
That will be like basically based on the driver and subtype combination. You will have a different CSI driver object, or is it one?
We could have multiple instances of CSI driver, or we could just change CSI driver to also have new fields that are of this style with a map string to something, so that you could then on a per subtype basis get different options. So like FS group change policy could become a map, or we could add a second field that was the map for FS group change policy, and then we could look up based on the subtype what the policy is. It would be a little bit more complicated, but the point is it would be entirely inside Kubernetes. It wouldn't have to change the CSI spec. The CSI spec change would be basically these two fields. That was what I was trying to emphasize here. The alternative, if we want to go back to more of like the option 2, would be to, rather than forcing Kubernetes to keep track of this subtype field, we could just add a bunch of new CSI RPCs that basically allowed kubelet or the sidecars to, on a per volume basis, just query, like, for this volume, what is the FS group change policy? For this volume, what is the FS group change policy? And they could just pass in, the idea has today, which is, I think, the string. So if we wanted to do more of an option 2 approach, Kubernetes wouldn't have to store this, but then every time it wanted to get the value, it would have to go ask the CSI driver.
Can you repeat what is option 2 again? I forgot. What is
Let me scroll all the way down so that we're on the same page here. The initial proposal was the high-level solution option 2 was solve each problem individually by approving the CSI spec as needed.
Okay.
So the idea is we could, instead of having the concept of a subtype, just make Kubernetes ask the CSI driver every time it wants to know about something specific about a volume, right? We could say, for this volume, what is the attach limit? For this volume, what is the FS group change policy? For this volume, what is the SE Linux policy, right? And then those would all be new CSI RPCs that you'd have to add to the CSI spec. And so that's a lot of work and a lot of change in the CSI spec. And what I wanted to point out was this allows us to avoid lots of CSI spec changes and basically push all the complexity back into Kubernetes by just having one new key, and then keep all the other stuff out of the CSI spec, with the exception of the volume limits or the node limits, as we talked about. So this is the general shape of the sort of the combination 1 and 2 that we had talked about last week. It's not beautiful. Like, I mean, it's still a little bit gross. It's still going to require some changes, and it's still going to have words. I mean, because you're going to have this weird stuff like a separate field max volumes per node and a map of max volumes per node.
Basically, like you would, depending on, so they will just support one of those, but not both, right?
No, you would. That's the whole thing, is you'd have to continue specifying this for backwards compatibility reasons, right? This would be the global max volumes per node for that particular CSI driver, because older versions of Kubernetes.
So saying that that code we do not change it, but it's like we're adding this additional.
But this is, if you know the subtype, you can look in this map, assuming that you have a new enough version of Kubernetes to get a different limit that is potentially lower or higher, and potentially get better behavior. So I just wanted to point out that, like, I think this is relatively lightweight and simple, but it's not totally perfect. And I just wanted to sort of poll the room and say, does anybody hate this as the path forward? Like, do we need to seriously go back and look at, option number 1 or option number 3?
Matt, his hand.
I'm sorry.
So
go ahead.
Yeah, I kind of agree. Like, I can see this whole subtype, having to kind of duplicate everything with this subtype field is, I mean, I agree. It seems a little warty. What about instead if we looked at something that, like, the couple of ideas that I have is that, one, if we had separate CSI drivers per subtype, like from the Kubernetes side, that would work fine. The problem, of course, is we don't want a ton of drivers to install. And then the second thing is that the subtype really is, expressing the same thing as a different driver. How about, like, what if we could do something where we allowed the same server to respond to several different driver flags?
Okay, well, hold on. So I agree with you in principle that it is like creating more CSI drivers, but it has the crucial difference that all of the different subtypes of a given CSI driver do go through the same create volume funnel and can use the same storage class. And as we discussed when we tried to go into detail on how was it option number 1? Just find my notes to be absolutely sure. Splitting existing CSI drivers to support multiple volume types into different CSI drivers. Yeah, option number 1. When we were talking about that, we realized that, like, you would be forced to have a separate storage class per CSI driver, and there would be no way to let the CSI driver choose the type of volume for you. You would have to choose by your choice of storage class. And furthermore, there's all the other just very practical challenges around having a large number of CSI drivers installed in a cluster, right? Like two is one thing, but like as soon as you get to 3 or 4 or 5, it's like, okay, this is crazy.
Yeah. So the first point about the different storage classes is good. What I'm suggesting is the second point isn't actually needed. Like, is there any fundamental reason why we couldn't have the same server handle multiple CSI driver types?
I see what you're saying. You're saying somehow change the concept of the CSI driver in storage class to be like a list.
Yeah, or I mean, I don't even know if you need to do that. I mean, like, I don't see why you could not just have the same binary happen to respond to all sorts of different driver types.
Well, the issue is the moment you create a PVC, let's say, for instance, you have 3 different CSI drivers installed, right? They're all running their own external provisioner sidecar.
No. I'm talking about a single
okay.
controller that just happens to say like, hey, I handle nfs.pd.com and or NTFS
right.
and
Okay. I get what you're saying. Okay, so I have one CSI driver that has both support for iSCSI and NFS. I have 2 storage classes, my NFS storage class and my iSCSI storage class, and I've just tricked the external provisioner sidecar to watching both of those and sending both of them to that particular driver.
Yeah, I mean, and this, like, probably the cleanest way to do it is to change the external provisioner and stuff.
Yeah.
So that all of that, like, understands that there could be the same backend handling the same thing.
But the problem I still see there
is with that we wouldn't have to change the Kubernetes scheduler and stuff to speak these. But I do see that's your point about having to have a different storage class per thing.
And the issue is only one of them can be the default. So if you have an iSCSI storage class and an NFS storage class, one of them is going to be the default, and you're always going to get that one. So the way one of the reasons I think that people are doing the subtype thing now is because they want to have a single storage class and a single CSI driver that funnels all the requests in there and then lets the driver decide to give you, a different protocol depending on what you asked for, because it can have a lot of intelligence down at that layer.
Yeah. Actually, a question for Jing seems to be on the call. Would this help the Windows stuff? I mean, like, I know we had spoken about explicit support for understanding the different file system, but maybe this could be a way to simplify that.
So the current design, right? It basically can handle no matter it's Windows or Linux. In your storage class, you just have one default storage class, and based on the operating system on each node, it can figure out what file system it should use. For Windows, it will be using NTFS, and for Linux, it will be default to ext4. So that's the current situation.
But the current situation is you leave it blank and take the default.
Right.
But this is something that we had to change, right? Because it did not work that way in the past. We had to explicitly specify NTFS because the default had been ext4.
There are already changes that make this kind of available. The only thing for PD, GCPD is we have somewhere like have an additional parameter setting. I think in the provisional controller somewhere, we set default to ext4. So no matter it's Windows node or Linux node, that's the reason. And we didn't change that yet. So because we worry about someone depends on, because remember there is the drawback of PV will not have file system filled up if we do that way. So because at the provisioning time, we don't know what is the file system I'm going to use. So we haven't changed that behavior for GCPD yet. But if we don't add that parameter, I think in the controller, like provisioner somewhere, then yeah, everything should work. So
Right,
it can figure
because
out.
yeah, because here the subtypes added to the PV, so like this change would actually solve all that on its own, because
So
we could have the same default storage class and all that stuff, and then the PDCSI driver would just stamp a subtype that is like Windows or NTFS or something, and then it'd be tracked in the PV.
Okay, I see. So for subtype, it's some arbitrary string like defined by driver side.
Yes. And we would have to, from the CSI spec, sort of explain how it's meant to be used, but it could be pretty vague.
So why we call it subtype? We don't have a type.
Sub. I mean, I don't care about the name of the field, to be honest. If you have a better suggestion, but yeah, it's like it's a sub key under the driver name, right? It just needs to be a key. And we don't want to pick something that has semantic implications like protocol or volume type or volume mode or any of those things, right?
So it gave like the driver to handle like what name you want to put there.
Right.
Like
so for the NetApp one, very specifically, this would be iSCSI or NFS most likely, and then over time we do have a few others that we're adding. But yeah, like we would just pick appropriate strings for each of those and stamp them, or we would just return them in the volume object from crate volume, and then we'd expect them to get stamped here. And then, if the way that this was used was to look up some policy in the CSI driver's CRD, we would put the appropriate things in that CRD so that they mapped to valid values.
We call it subdriver type. It's more clear.
Sure. I mean, we the exact name I think we would want to agree on, get buy-in. Of course, we would need a KEP to do this. It would have to go through alpha, beta, yada yada, and so I'm sure we would get API feedback on what they want to call it. So the exact name we're a long way away from agreeing on, but but the main thing was, if we do it this way, it saves us from having to make lots and lots of CSI spec changes, because it basically gives us one extra key that Kubernetes can key off of for all of its proprietary decision making, like the FS group policy and the SE Linux stuff that we don't want to put into the CSI spec proper.
So how much like a kubelet side change will involve?
Well, the kubelet would have to, there'd be a feature gate around this. So if feature gate was turned off, it would just do what it does today. If the feature gate was on, it would look at this field, and anytime it was non-empty, it would do something different than what it does today, right? Either by looking up, in this map for the max volumes per node, or looking up in the CSI driver CRD for FS group policy or anything else.
Those are information will be retrieved during volume, like attachment and mount.
Yeah. FS group policy matters at attachment time on the node. Similar SE Linux labeling, I think, matters at attachment time. The volume limits, of course, matters at scheduling time. So whatever is currently pushing that information from the node to the scheduler would have to, push it. And then the scheduler would have to be aware of these things at scheduling time.
Does this involve more API calls, or it should be almost the same as before?
Number of API calls wise, I think it's exactly the same. That's one of the nice features, because we're not adding any new RPCs. We're just adding this extra key that you can use then to disambiguate volume types. So we can tell you that.
But we need to, like, in addition to getting this maximum volumes per node, we need to get this one, right? So is that like, oh, you're saying we just make one node get info call, then we'll get both, basically.
Yeah, and then and if this field is populated, you shove that into whatever kubelet is currently sending to the scheduler. So we could need to changes at that layer as well, but it would be similar to this, where we would preserve the old field and add a new optional field for the more detailed information, so the backwards compatibility would be easy.
Mhm.
Because we would just define, that it's always legal to ignore all this stuff and just do it the old way. Because the way it works now is okay. This is just a strict optional improvement for volumes that do subtypes or subdriver types, if you prefer that name. So Matt, you sort of spoke against this. Are you still kind of hating it, or are you ambivalent? What is your stance?
My stance is conflicted. I mean, like,
Yeah.
I am like nervous that having to plumb all the subtype through is kind of like is going to get increasingly messy.
Yeah, I
It would
mean,
be
this is not a panacea,
cool.
but
Yeah, no, I'm just thinking because if the in the Kubernetes side, it'd be nicer if there was just like an opaque like, and a single opaque thing that it gets for each node.
right.
But I mean, this thing of having it tied to the storage class is certainly hard, because like there are these use cases where I mean, like, I guess basically what we're talking about is we kind of want the driver to stamp extra information on the PV. So maybe it's unavoidable that this is like truly a new bit of information that can't be captured in the driver, even from the Kubernetes side.
Well, it's the only way to sort of give Kubernetes the ability to tell the difference without, making it ask on a per volume basis, what to do with any particular volume, while also preserving the ability to just have one storage class that's your default that maps to all of your subtypes and lets the driver decide. So like
Yeah.
any other option gives up one of those two benefits. And
Mhm.
the other thing is, I hope we can convince ourselves, like, in principle, this is doable in 2 releases, right? If we set up the KEP and write it up and get it approved and do the CSI driver work and do the kubelet work, you could have it be beta in the release after that and usable. And so a 2 release turnaround time to actually solving the problem. My big concern with option number 1, while I believe we should do all of the things that that have been mentioned about making the sidecars less onerous and making the node plugins able to start up and shut down, and all those things are good. I just have no faith that we could get those done in a reasonable amount of time.
Oh, yeah, absolutely.
So
I mean, and besides, like, as you said, even if we had that, that still doesn't solve the problem of having a single storage class that gets extended based on information the driver knows at provision time.
So
I mean, like, that seems to me kind of like the key thing we've identified here is that, like, we want extra information stamped on the PV, basically. Yeah.
This one does not depend on the storage class, right? So it doesn't matter whether it's 1 or 2 storage class, right?
Right, exactly. You could have 2 storage classes that are both pointing to the same CSI driver.
Yeah, because I think that's what in our case would be like 2 storage class.
Yeah.
1 for file, 1 for block.
Mm-hmm.
Okay. So if no one else has any comments or criticisms, I'm okay with sort of wrapping this up and reconvening in a week with hopefully a wider audience. I'd like to sort of get buy-in from everyone who's actually interested in solving this, because I don't see a way to, in a reasonable time frame, actually get this addressed. And if we decide like option 1 is where we want to go long term, I think that just means we're basically just not solving the problem, and we're just nibbling around the edges of some of these other problems, like the memory footprint of the node plugin and the complexity of dealing with lots of sidecars. And we should do those things, but I don't see the actual per volume capabilities getting addressed through that mechanism. So, and it would be fine if that's where we ended up, right? This is a proposal that I think would make things better, but it's not do or die from my perspective. We're limping along in the status quo. We can continue to limp along if we have to. So if we come down and say we don't want to do any of this, that may be the outcome. But I'm hoping that this is not too bad and a path forward.
Yeah. So perhaps I think you've kind of basically convinced me. I still feel like this Kubernetes plumbing for the subtype is messy and could be improved, but maybe actually the most expedient way to deal with that is to start the cap, and then in going through the detailed Kubernetes side design, we can either improve things or convince ourselves that this is the best we can do.
Yeah, I like that idea.
That might be best addressed
pulling in more
the,
Kubernetes people and getting opinions on the exact changes that would be needed. Okay.
Yeah, I also agree. Like option one, I feel there is so much downside, and I feel I want to avoid going that direction. And when we focus on like new things, at least for Alpha, right, we want to try it out to see how it works well. It's worth trying. Yeah.
Okay.
It might be good for any new feature. We could look at using this. Like if we need to add any new capabilities in CSI, we can look at this one.
Yeah, we would, assuming that we're happy with the Kubernetes side changes, there would still be that one CSI spec change. We would have to convince the CSI community that this isn't just some wormhole that we're going to shove a bunch of functionality through, and that it actually means something, concrete. But we could. I'm pretty sure we could wordsmith that for the CSI spec.
Jean was actually thinking about the volume group. Like one particular thing is for block volumes, you can actually add existing volumes to the group, but for file volumes you cannot, right? So that's one thing. Depending on the subtype, you could do this.
Oh yeah, yeah. Groups get really complicated, and
right. I'm just saying that would be something that this in the subtype thing might help.
Yeah, it would at least give us another tool to disambiguate, and then you could have more rich capabilities expressed, on a per subtype basis potentially.
But of course, that's adding another dimension.
Yeah. So from design point of view, right, a driver should be able to handle different, I don't know, characteristic of volumes or features, right? It's not possible to just have one driver for every single different, I don't know how to call it, volume type or different word.
Well, I mean, you can get pretty far with the existing CSI spec in a single CSI driver. It's just that some of the special stuff we've put into kubelet, like the FS group change policy and the coming SE Linux stuff, turns out to not work the same all the time. And
not only the kubelet side, right? The controller side as well. We also have those problems. I know you could use some workaround, but not pretty.
Yeah, well, I mean, the CSI driver itself, it should know what type it's dealing with any given volume and what it can and can't do. It just can't tell the sidecars about that information, right? The sidecars have to assume every volume is the same capability-wise, whereas the driver itself, of course, it knows.
So a driver should supposedly handle different, let's say, storage class, and let's say each storage class has different, how to say, property of the volume, and because of this difference, you probably have different values or capabilities.
Yeah, absolutely. I mean, you can always have more than one storage class, even if you only have one CSI driver, and you can specify as much detail as you want. But I'm pretty sure that the common case in most places is just one storage class, and you just use it. I think I get the impression that that's what most people do.
But normally you would have multiple storage classes, right? So they would It's for different things.
So
I mean,
Like for like service level or something, right? Did they have something?
potentially, if you're deploying like apps from manifests, app manifests don't say anything about storage classes, right? The storage class field is always empty in an app manifest. So in a lot of cases, you're just going to get the default, right? Because you're using something off the shelf that doesn't specify a storage class, and it's willing to accept whatever you give it. Of course, if you're doing more custom things on a particular cluster and okay, I have a gold, silver, bronze storage class, and this app needs to be gold, then of course you can specify that. But reusable off-the-shelf stuff tends to just work, cross-cluster and doesn't specify a storage class as a result.
So you mentioned that like if using multiple storage class, there still needs changes, right, to be able to handle all the use cases mentioned here.
Excuse me. Not necessarily. I mean, you can have multiple storage classes today. You can continue to have multiple storage classes after this. It'll just be that when you actually get a particular volume, you'll know what the subtype is.
Well, like we always use a different storage class for one for block, one for file at least.
Right. So
right.
So the vendor could
minimum.
set things up such that all the volumes created by one storage class will have one subtype, and all the volumes created by another storage class will have a different subtype. But that would be a choice that the vendor would make, right? It would be more common to.
But will that solve problem already? No, right?
No, it does not, right? That's because we can only report one capability per driver. Doesn't matter how many types you have. Right?
I mean, so the perfect example is, with a NetApp driver, if you ask for an RWX volume, you are definitely going to get NFS. If it's an RWX file system volume, right? Because we can't do that with iSCSI. And so all we need to know is, the storage class is the NetApp one, and the access mode is RWX. And based on that, we can say, okay, we're giving you NFS. But if you turn around and use the same storage class and ask for raw block volume, you're definitely going to get iSCSI because we can't give you an NFS raw block volume. So again, like that's just, we look at the specifics of the PVC and the volume capabilities that are coming in through the CSI layer, and we decide what can we give you that would match your needs. Now, if you ask for an RWO file system volume, then we could give you iSCSI or NFS. It doesn't really matter. And at that point, it's just going to be up to the driver's preference or wherever we have space or whatever makes sense. But there are certain cases where, depending on the details of the PVC, it forces us down one path or the other because certain subtypes can't do certain things. We also sometimes switch on volume size. Like if you ask for really small volume, we'll give you more of an economy style volume, whereas if you ask for really big volume, we'll give you a different kind of volume that has higher performance.
Yeah, so that's part right. I'm just saying, with the current capability, right, is now solving the problem. Like for example, the maximum volume per node issues with multiple storage class, or I'm not sure FS group. It can also now solving that problem either, right? So you still need to have a way to.
Right, the storage classes don't solve those problems, but either the subtype or multiple CSI drivers could solve those problems.
Right. I'm just because you mentioned the single storage class and the multiple storage class. I'm just want to confirm, even have multiple storage class will not solve problem. Like here, the proposal you have here solve the problem. Yeah.
Right. Yes. Yeah. I mean, multiple storage classes are fine, but they don't help in any way that I can see. They're just something that people use.
Right. So if you could add, here you already give the some new API added for, let's say, CSS spec, and maybe if possible to add end-to-end flow, starting from storage class to PV to.
We can flesh out this design in actual KEB if we get buy-in. I'm most concerned about Michelle because she was the one that was pushing for option number 1 in the first call. We don't have her today, so I want to go. I hope she can attend next week, and I hope we can get a discussion about that. Because if she's okay with this, then and no one else is going to push back on it, then yeah, I think the next step is turn it into a KEP and get the appropriate reviewers to start reviewing it, and hopefully that will fill in all the details you want to see. But if she continues to be opposed to that, or if we can think of other reasons why this is a bad idea, maybe we just decide not to do anything, or to slowly chip away at option number one, but not really try to solve this problem in the immediate term. Because combining sidecars, improving the way node plugins run is just going to be a long project, I think.
Sure. So I can ping her like about next week meeting. So
Okay.
to make sure, yeah, we can attend. Yeah.
Yeah, she said today she has a conflict today.
Mm-hmm.
Oh,
So anything else before we wrap up? I'd like to give you 15 minutes back. If not,
I think this sounds good. I think we have a plan forward.
all right.
do you want to talk to her, Matt and Jean, maybe?
Yeah,
Michelle about
absolutely.
this. And there's also recording, so well.
Yeah,
Recording
absolutely. Yeah,
She can also listen to this as well.
Yeah, exactly. We'll speak to her. Perhaps we can, do a discussion offline if she can't make the meeting next week. But yeah, we will definitely follow up.
All right.
Yes.
Well, thank you all. Until next week.
Bye.
Take care, Ben. Thank you.